And everything we've done up till now has been considered a combination, a permutation question. Permutation question is we're worried about the order of things. What comes first, what comes second, what comes third. But there are a bunch of things that the order doesn't matter. Lots of card games. Doesn't matter what order you got your cards. Here, you won a contest in which you won 3 books. And there's 4 books to choose from. Whatever order you pick your books doesn't matter. It's not like you pick book A, B, and C, and you're like, no, I'm going to change my mind. I'm going to put them back. I'm going to take home book C, B, and A instead. They would look at you like, you still have the same 3 books. The order that you won your prize doesn't matter that you pick A first and C last. You get to keep those 3 books. So what we look at is that if you chose books 1, 2, and 3, that's considered one combination, but in permutations, there would have been 6 of them if you picked books 1, 2, and 4. In permutations, there would have been 6 of them. If you look at all the ways you could arrange 3 books, make 3 decisions, like permutations would say, we have 3 decisions to make. Which book are we going to put first? 4 choices. Which one second? 3 choices. Which one third? 2 choices. And you would get 24 in total for permutations. But combinations doesn't have the order. So basically, what a combination is a permutation where you divide out the order. How many ways can you order 3 things? You can order 3 things in 3 factorial ways, right? 3, 2, 1. So each of those would be identical, like identical objects you have to divide out. We divide by 3 factorial, which is 6, and there would be only 4 combinations compared to 8 permutations. So the formula for combinations, which is on the next page there, is just your permutations formula with the order divided out. So however many spaces you had, that's the however many things you have ordered, you are dividing by that additionally. And remember how we hardly use the NPR formula? The combinations formula, we will actually use a lot more. Because there's not a spaces method for it. So to recognize when something doesn't have order, and you see it is a combinations question, you are going to use the formula. And
sorry for the interruption. All JV boys basketball team, can you please head down to the office? That's JV boys basketball team. Please come to the office.
And the combinations formula is really easy to memorize. Because if you have, say, 7C2, you'll have a 7 factorial on the top, you will have a 2 factorial on the bottom, and you will have another number so that the bottom 2 numbers always add up to the one on the top. So if I had 8 choose 3, I would have 8 factorial on the top. I would have 3 factorial on the bottom, and what adds up to 8? So it's super easy to remember for that reason. Now on our calculator, it looks, okay, on our calculator, and we will always write it like this, okay? You will see some textbooks write it in brackets like this. That's how the IB curriculum used to do it. And then the IB wanted to sell new textbooks, so they changed it to this now. It's like no one can decide. But they're like, if we change it to this, then maybe schools will buy a new textbook and we can make money. Anyways, we will use this one with the little n and the little r, just like our permutations one. So when we look at example number 1, what's going to happen on your exam, well, you don't have it on your exam, on your test for this unit, when you read a question, the very first thing you're going to have to ask yourself, is it a combinations question? Is it a permutations question? Does the order matter, or does the order not matter? If the order doesn't matter, then you've got a combinations question. Okay? Sometimes they have it really obvious, but they say, how many combinations are possible? So, 20 numbers from 1 to 80 are chosen. It is as easy, wow, it's a bad 80, as writing this. Technically, this would be 80 factorial over 20 factorial, 60 factorial. Those are all very big numbers, but your calculator can figure that out. Should find the combinations button on your calculator. Type in 80, find the button, then type in 20. 80, for me, under math, go over to probability, number 3, 80, choose 20. A lot. 3.53 times 10 to the 18. You see the e to the 18 at the end? Okay. Now, has anyone ever played the Keno lottery here? No. Have any of you heard of Lotto 649? Okay, that's probably the most common lottery in Canada. The way that we can now figure out the way that Lotto 649 works. The way that Lotto 649 works is they have 49 balls numbered from 1 to 49, and 6 of them fall through a thing, and if you happen to have those 6 numbers, you win the lottery. That easy, right? I won it 5 times last week. So, why is it so hard? And the order doesn't matter. So, you chose number 5 as your 5th choice, because you thought that would be lucky, and 5 comes out first. That doesn't matter. You still got one number right. So, for Lotto 649, the order doesn't matter. And so it becomes a combinations question, and now we can count it very easily. How many different combinations are possible is just 49 choose 6. And if we do this on our calculator, okay, this is going to be very exciting news, because I'm going to tell you, if it's one of your goals in life to win the lottery, it's possible. We're gonna figure out how you want to win the next lottery next week. We can do it. Just watch, okay? And go 49. Choose 6. 13,983,816 different possibilities. You want to win the lottery? You just have to buy every single possibility. You're guaranteed to win. If you buy all 13,983,816 tickets, you will have every combination, and you will win the lottery, guaranteed. How much does it cost? I think it's $2 now? $2 to play? You probably don't know. You don't play the lottery. I don't play the lottery because I know the chances of winning are so small. It's not worth it. But times that by 2, 14 million about. It's going to cost you, you want to win the lottery, you can do it for a measly $28 million. Guaranteed. Guaranteed win. Only cost you $28 million. So next time that the lottery is at 35 million, you could just buy all the tickets and guarantee that you'd win. What could possibly go bad? 2 people win. Right? You split 13 million, 17 million. You're only what? Only down $9 million? You can make that up the next week, right? So, yeah. I tried, went to the bank, said, could I borrow $25,000 $28 million, please. And they're like, why? Going to win the lottery. They said no. Right? Problems are exactly that. What happens if somebody else wins? Then you have to split it, and then you would be, they just file for bankruptcy and go to a different bank the next week. Eventually, no one else will win, and you'll be good, right? I'm sure the banks would love to give you that money over and over and over again. So, however, if you are planning on playing the lottery because you need to win the money, that's not a good strategy in life. Your chances of winning are very bad, okay? As far as how bad is very bad, there we go. Yes, take out a nickel if you have a coin, quarter, whatever. Here I have a penny, okay? Flip the coin. I got heads. There's a possibility I could get heads in a row twice. Good. How likely would it be to flip a coin 23 times in a row and get heads? It's possible, but it's very unlikely. That is about the same. It's in between 22 and 23 times flipping a coin is about the same as winning the lottery. So maybe go home and flip the coin. Once you get to 20 times in a row, go buy a lottery ticket. If you haven't hit 20 times in a row, don't go buy your lottery. Because chances are very, very, very likely that you are not going to win. However, if the $2 that you spend on that lottery ticket gives you the best daydream of your life for the 2 days before you find out you didn't win, right? And that daydream, in your opinion, is like, oh, what would I do if I won all of that money? Like, oh, and you start imagining all those things. You're not allowed to have that daydream unless you have the ticket, right? Because if you haven't bought a ticket, there's no chances of winning. So if that daydream for you is worth $2, then play the lottery, because you get entertainment out of that anyways. If, right, for me, I daydream about finding a lottery ticket on the street, and it's the winner, and then it doesn't cost me anything, and I still get the enjoyment out of the daydream, but it's a free daydream. It happened to me once in university. I was daydreaming about finding a box of gold, and I said to myself, okay. I didn't refer to myself as Mr. J. Okay, this is a ridiculous daydream. It's not possible. Right. Well, what if I found, like, some gangsters who are throwing out a roll of cash? Okay, this is Winnipeg, and gangsters usually don't just throw out rolls of cash. So I was trying to make it realistic as I'm walking to university, and I finally went, what happens if I found a gift card? And 3 seconds later, there was a gift card on the street. I was like, this is awesome. $25 gift card for a music store, because music stores don't exist anymore, because you can just get your music online. But I went out and bought a CD with the gift card I got. Anyways, this is combinations. Let's go to example 2. Circle the questions 4, 5, and 7. Oh. We gotta switch mics.